Greetings, detectives. Mrs. McKay here, and we're working on case 6, which is systems of equations. And we're going to start by doing clue 1. I can solve a system of equations by graphing. Now, a system of equations, you may be wondering, is just a group of two or more equations. And in this situation, we're going to be talking about linear equations. So a group of, having a little bit of problems there, a group of linear equations, two or more equations. And if we were going to graph those equations, they would look like lines. And we might, let's say we had 3 of them. And there's 3 lines, 3 equations, and the system is the 3 equations, and the solution to that system is where those equations intersect, right there, that point. That's what we're looking for. What do those 3 equations have in common? So we look for where they intersect. If we didn't want to graph them, we could still figure it out algebraically by simply trying to find what is the common point that all 3 equations have, that the x and the y values make, that it's the same x and y value that makes it a true statement. So that's just a quick thing with systems of equations. Now, the thing about systems of equations is that basically a system of equations can have different types of solutions. So if we have 2 intersecting lines like this, and say that, okay, then we look for, if we have 2 lines that intersect, there's only going to be one solution, and that one solution is right there. And in this case, it looks like it's 1, 1. That is the point that the 2 lines have in common. But sometimes when we graph our systems of equations, we might end up with something like this. Parallel lines. Now, parallel lines have no intersecting points because the 2 lines never touch. So that means that they have no points in common, and therefore there are 0 solutions to this system of equations. And the next one, we may have 2 equations, and when we graph one line, we get something like that. And when we graph the second line, we end up realizing that it's really the same line, that they just lay on top of each other. And when that's the case, every point is in common with the other line. So the 2 lines have the exact same points, and therefore the number of solutions is infinite because every single point on the line is the same. So you can say infinite, or you can write infinite like that. Okay? Let's go ahead and do some samples. So here I have solve a system of equations by graphing, and I have 2x minus y equals -3. Now, and then I have another equation that's 8x minus 4y equals -12. And what I want to know is, where are those 2 lines intersecting? Do they have a common point? So I can do it many different ways. And the way I'm going to do it this time is I'm going to go ahead and put the equation in slope-intercept form. So I'm going to put the 2 lines in slope-intercept form, and I'm going to end up with this one, 2x minus y equals -3. I'm going to go ahead and pause this and figure that out, and you do the same thing. Okay, so I've done some work, and you can see I've done the first equation in blue, and I ended up with, I subtracted my 2x, and I got -y equals -2x minus 3, multiplied everything by -1, I got y equals 2x plus 3. So I'm going to go ahead and graph that line. I'm going to start by going up to 3, putting a point right there, and then I'm going to go up to over 1, and I'll go down 2 over 1. Okay, and there's my line. Okay, now my second equation that I did, I had negative 4y equals negative x, 8x minus 12 because I subtracted my 8x. Then I had to divide everything by negative 4, and I got y equals 2x plus 3. That sounds kind of familiar. So, but let me go ahead and graph it. I'm going to go up 3, put my y-intercept there. I'm going to go up 2 over 1, and down 2, back 1. And again, you can see that my line is the same line. So in this situation, I have infinite number of solutions. This has, because they are really the same line. All right, let's do the next one. This time, when I solve this one, I'm going to go ahead and use my x and y intercepts. You can graph it any way you want, but I'm going to graph it using x and y intercepts. So go ahead and graph these two lines. You can either use slope-intercept or you can use x and y intercepts. Okay, so this time I went ahead and figured out my x and y intercepts. So for my first line, I had x minus 2y equals negative 4. So I made the x be 0, and I ended up with negative 2y equals negative 4. And when I solved for y, I got y equals 2. So my first point is 0, 2. So let me go ahead and graph that for my first line. 0, 2 would be right there. And then my second point, which would be my x-intercept, I made y be 0 this time, so I put 0 in for y, and I got x equals negative 4. So my second point is negative 4, 0. 1, 2, 3, 4. So negative 4, 0. And then I can connect my 2 points, and there's my first line. I did the same thing for my second line, and this time when I figured out what my x-intercept, what my y-intercept was, it was 0, 1. So I plot that point right there. And my x-intercept was negative 2, 0, negative 2, 0. And I graph my two lines, and I notice something. I notice that my lines are parallel. If I had graphed these in slope-intercept form, I would have had, well, you can see, even just looking at them, that the slope is up 1 over 2. So my slope of this line is 1/2, and my slope of this line is up 1 over, is 1/2 as well. So because they have the same slope, they are parallel lines, and therefore they have no solutions. Okay, no solutions. It's a null set. We're going to do the very last one. I'm going to pause it. You graph those two lines, and we'll find where they intersect, if they do or not. Okay, so I had to move everything down, and then I had to erase my screen, so I kind of redrew a few things. But let's go ahead and look at this one. Y equals negative 6. Y equals negative 6 is just a horizontal line. It means that no matter what value x is, it's always, the y is always at negative 6. All right? So that's just a horizontal line going across. That was my first equation, y equals negative 6. My second equation, 4x plus y equals 2, I went ahead and put in slope-intercept form, and it became 4 equals negative 4x plus 2. So I graphed, I started at my y-intercept of 2, and then I went down a slope of 4, down 4 over 1, down 4 over 1, and right there, at that point, is where my two lines crossed. Everyone see that? So that means that this point right there is my solution, and whatever the value of that point is, or whatever the coordinate of that point is, the value of x, the value of y, will make both of those two equations a true statement. So so we say that it's 2, and it goes down 1 to negative 6. And that's the solution, one solution. I've got some key steps over here that help you to know how to solve it. And all that you have to do now is write your key idea, and I'll see you in class.